Calculus obviously has a lot of uses in a lot of different fields, from biology to physics to chemistry. But one particular place where calculus can be very helpful is in financial mathematics. Specifically when you're talking about cost and revenue and profit and a lot of the major things that you would think of as a business owner. If you think about it, really the fundamental goal of most businesses is to maximize your profit, not just make a profit, but make the most profit that you can, or to minimize your cost. And so when you're talking about maximums and minimums, you naturally think calculus, because you have, relative maximums and relative minimums. And if you could somehow find a function that represents your cost or revenue or profit, then you can take derivatives and use increasing and decreasing intervals and extrema and concavity and all these sorts of things to your advantage as far as finding the maximum profit or the minimum cost or the maximum revenue. So one particular topic in relation to calculus and these financial topics is something called marginal cost or marginal revenue or marginal profit. So here's what it is, and I'll explain this in the context of marginal cost, but it's the exact same idea for marginal revenue or marginal profit, but I'm only going to talk about this in relation to marginal cost. So marginal cost would be the change in cost or revenue or profit as the production level is increased by 1. This is a very important idea that's often very, very important for businesses, is to know how much more am I going to spend making one more toaster oven or television or tennis shoe or whatever the case may be. So here's a cost function, and what it's representing is the total cost of producing X number of items. Now, you would expect this cost function, total cost, to continue to go up, because as you make more items, you're going to spend more money making all of those items. So we see that it's increasing here. Now, what the marginal cost would be the change in cost for producing an extra item. So you can kind of see that quantity here. Is this change in cost here. So one thing that we realized that could help a lot is if you could somehow find the slope. If you could somehow find the slope at a given production level, then you see the tangent line roughly follows the curve. As a matter of fact, if you could find the slope of that blue line right here, let's say it's a slope of 8. Well, then what is the number 8? Well, that's $8 increase in cost per 1 unit made. 8 over 1, rise over run. Well, that's precisely what we're looking for here. So if I scroll to the next page here, if C of X is your cost of producing so many items, then the derivative at X will be your marginal cost. That'll be how much more it would take to produce one extra item. And then likewise, if R of X is your revenue of producing X number of items, then R prime, or the derivative, would give you your marginal revenue, which is the change in revenue for producing an extra item. And then profit, if you just think common sense for a minute, how do you determine profit? Well, you take all of your revenue, you take how much money you made in total all together, and then you have to subtract out the money that you spent on materials or labor or whatnot. That's how much you bring home in your pocket. That's your actual profit. So you do revenue minus cost. Now, if revenue and cost are both functions of X, when you subtract them, you would obviously just get another function of X. So you have these three typical functions, cost, revenue, and profit, and their marginal cost, revenue, and profit functions are simply their derivatives of C, R, and capital P. All right, now we'll do a more thorough example in the next video, but I just wanted to do one quick example just to kind of help you wrap your mind around the idea of marginal cost. Here, what we have is a function, and you tell it the number of items that you're going to produce, and the output will be the total cost that it takes to make that many items. So if you plug in 10 or 100 or 1,000, it's going to tell you how much it costs to make all those items. So the marginal cost, as we've already discussed, will be the derivative of this function. So we'll get 3 plus 0.2x. I'm sorry, 0.02. 0.02x, just using basic derivative rules. Now, the derivative of C, this will be the change in C over the change in X, often written dC dx, just like dy dx, like when we were learning about derivatives here. So if we tell it an x value, this will give us the slope of the cost function at that given x value, which if you think about it, that'll be the change in cost as you make one more unit. So what's the marginal cost if we produce 106 units? Well, we'll take C prime of 106. So here, if we do the math, I'll get my calculator out real quick here. We'll take 3 plus 0.02 times 106, and we get $5.12. So this is $5.12 for one additional item that we're going to make. So, and that's specifically the slope at 106. So if you can imagine here, I'll draw you a quick little graph here. So if you're at item number 106 right here, and you're looking at the slope, the tangent line right here, this will be a change of $5.12 as you increase your production level by 1. So between the 106th and 107th item, you expect to increase about $5.12 or so. Now, is that the actual change in cost of producing just the 107th item? Not exactly, because there is a small discrepancy here. If you look, there's a difference at the 107th item between the actual change in height from here to here on the curve, on the cost function, and what it's approximated by on the tangent line. Now, they should be very, very close, within a couple pennies in most cases, but it's not the actual change in cost. So if we look at the next question, what is the actual cost of the, well, actually, let's just say 107th item? How much does the 107th item cost exactly? Well, really, the only way to find this is to find the cost of making 107 total items. Now, this is going to be a massively big number, because that's going to be the representative cost of making the first, the second, the third, the 100th, all the way through the 107th item total. And then we'll take away the slightly lower cost of making just 106 items. And so if you think about it, all that's left when you take this difference is just the last little part of creating that 107th item only. Now, I went ahead and typed in this function into my calculator. Here's the cost function. So if you go to your table, it's usually the easiest way to do this, and you type in 106, this will probably be a pretty big number. Yeah, $2,930.40. That's a big number representing the cost of making all those items. And then we plug in 107. That's how much it costs to make 107 total items. And here, if I cut this out so I can blow it up and you can see it a little better. Come over here, blow this up. Then you've got this slight change in cost. And so here, if I jot these down, 107, this costs $2,935.50. But to only make 106 was $2,930.40. If we take that difference there and subtract them, this will be, what is that, $5.10? $5.10. This is the actual cost of the 107th item. But check this out. This is pretty cool. The marginal cost gave us $5.12. The actual cost was $5.10. These are always very, very close to one another. This is why calculus is extremely helpful. If your cost function's nasty, you would not want to plug in 106 and 107 and 108 by hand. Heck, you can just use derivatives, and derivatives will quickly and easily approximate your additional cost of producing an extra item. And notice when you take the derivative, look how simple and small this marginal cost function was. Now, you can do the same thing for revenue functions and profit functions, but this was just a quick example just to kind of help you tie everything together based off of what I said previously about marginal cost and revenue and profit. So be on the lookout for the next video. You can go and flip to it right now, where we'll do a more in-depth example for marginal profits and revenue and those sorts of things.